We've heard about morphometrics on Cisco. We've heard about genetics in Cisco. I'm going to try and talk about basic biology of Cisco, something that most of us don't really talk about too much, in hopes of trying to place some more of this into context. What I'm going to do is I'm going to talk about Cisco populations that we sample on a fairly regular basis in three areas of Lake Huron. One in the upper St. Mary's River system, right along the west side of Sugar Island. This is where the group spawns. One in the LHC Islands of northern Lake Huron, and the other across the south shore of Drummond Island. You've seen these graphics. You're probably going to continue to see them again. What I'm going to be talking about basically are not so much the Ardii form, although the St. Mary's River sort of forms to be Ardii, but it's the Albus and Manitoulin forms. That's what these are. These are less strictly Ardii as they are these other, what I'm going to define as sort of a bay form or reef spawning form of Cisco. Most of our sampling strategy is bottom set gill nets, done over a large number of surveys, but over about the last 5-6 years now, we've incorporated suspended gill nets into our sampling strategy because Cisco are such a pelagic species that it makes perfect sense to be sampling up where they live most of the time. Essentially what we've created is what I call the Ebener modification of the Nordic net. It's a graded mesh monofilament gill net with the mesh sizes all sewn together so that there's no space between mesh sizes, whereas our bottom set nets are typical as most agencies fish in the basin. You got a 100-foot long net, you attach them together to form a gang. My sampling consists of a different large number of projects, but essentially we did sample in May in the Drummond Island Refuge as part of a lake trout survey. We would catch Cisco. We have a survey in July that started in 1999 that we do that targets lake whitefish, but we also catch Cisco. We have a survey in August that takes place every 4 to 5 years in the St. Mary's River system. During October, we also sample again in the Drummond Island Refuge targeting mainly lake trout, but we also do Cisco surveys. And then in November, we routinely sample at Sugar Island and in the LHC Islands. These are primarily Cisco target surveys, the last two. These are relative abundance of Cisco from each of our surveys. The upper left is surveys done in the Drummond Island Refuge. From the red bars represent large mesh gill nets of 4.5 inch and larger where we target lake trout. We also catch lots of large Cisco. The blue are small mesh gill nets. The thing to notice here is the big change in relative abundance starting in 1998. In the Drummond Island Refuge, essentially abundance jumped up tremendously and has been pretty stable throughout the whole time period. If you look at in the St. Mary's River surveys, we've used suspended nets, we've used bottom set nets. Again, abundance appears pretty stable. There's no real trends. The only trend that we see in the entire data set is for our summer survey in MH1, where we're basically fishing gill net gangs less than 100 feet, greater than 100 feet targeting whitefish. We took catch Cisco. This is the only place where we've seen declines or any changes in relative abundance through time. If you look at mean length of capture, all I want to do is indicate here, if you look at the upper St. Mary's, lower St. Mary's, Drummond Island, Detour, and Cedarville, you see a same pattern through time. Basically is in the early part of the time series, beginning in the 1990s, the fish average size was pretty large. We're talking up between 400 and 450 millimeters. See a big decline in the average size of fish caught through the mid-1990s, and then that sort of increases through time. And each of the data sets shows the same sort of pattern. So what you're seeing is that, really what I'm going to show you later is that there was a large recruitment event that occurred in the early 1990s. That occurred at all three sites, basically. The only difference is these fish here, these are from the lower St. Mary's River, essentially what's called the turning basin in the lower river in the Raber Bay area. These are caught as part of the survey in the St. Mary's River system during the summertime. These fish tend to be very small, and these are fish that come from about right here, and you see that their average size is considerably lower than other places. What I did was this is a graph that shows maturity, proportion mature fish by size, males and females combined between the three areas. Things that I want to point out here are two. One is the blue dashed lines in the St. Mary's River, you get a lot of fish that are sexually mature at a very small size, so 170 to about 240 millimeters. And then the proportion mature declines with size and then increases as you would expect a normal maturity curve. You see the same thing a little bit at Drummond Island, but you don't see it in the red lines at Cedarville. You get more of a normal maturity schedule. They start at 0 at small size and increase. All of them peak at about 300 millimeters. This is at 300 millimeters, basically every Cisco in northern Lake Huron is sexually mature. The interesting thing is these small fish at St. Mary's River, these are like chubs in terms of maturity. They're mature at less than 200 millimeters. I don't see this any other place. If you look at age compositions, these are age compositions across each of the sites. This is pretty interesting, I think. If you look at Cedarville in the top, you get a pretty typical age distribution. A lot more smaller fish and a lot more younger fish. Look at Drummond Island, you don't see hardly any fish, young fish. Most of them, the age structure looks like some of our lake trout populations, a mean age of 10, 11, 12, 13 years old. The upper St. Mary's, you see more of a truncated age structure. So suggesting each of these fish are experiencing different levels of mortality, whether they be fishing, whether they be predation, whatever it is. There's varying levels of mortality and recruitment at each of these sites. Another thing to notice is how old these fish are. Particularly at Drummond Island, we're seeing fish out to 23 years old. This is an older fish than what most people would have thought. And if you look at a lot of historic literature, especially when people are aging scales, everything's 3 years old, 4 years old, 5 years old. These fish are substantially older than that on a regular basis. Now what I want to do is I want to talk about the dynamics or parts of the biology of these species at each of the three sites, and it's just little snippets of data that I have. So in the Lachino Islands, we conducted studies here in 2011, 12, and 13 to evaluate putting a fishery in this area. Our regulations say that our fishermen cannot fish small mesh gillnets in less than 6 fathoms of water from October 15th to November 15th. But because of the big increase in herring fisheries for the roe fishery that Jared talked about this morning, our guys thought the opportunity would be there to fish Cisco to diversify the fishery, particularly with whitefish abundance starting to decline. So we initiated a fishery there where we fished suspended nets and bottom sets in less than 36 and greater than 36. So the take points here are that Cisco are the most abundant, and that Cisco abundance is pretty equal between less than 36 and greater than 36 feet. And that in basically less than 36 feet, we got lots of yellow perch, northern pike, whitefish. Most of the other species are found in less than 36 feet, and so the regulation sort of makes sense if you want to reduce bycatch. But you can avoid that situation if you use suspended gill nets. Again, Cisco, the dominant species in our catch, we made greater catches in suspended nets than we did in bottom set nets. And in the suspended nets, we caught basically almost all herring and hardly anything else. Whereas the bottom set nets, we caught basically everything that was there. If you combine these two data sets together, what you get is a picture by species of catch rates of less than 36 and greater than 36 feet. The thing to notice is that in the suspended nets, we basically caught no whitefish, no northern pike, no lake trout in greater than 36 feet of water. Drummond Island now, when we talk about mainly what we're doing is our sampling occurs across the entire South Shore. I try and sample as broad array of spawning reefs as we can during this time period. Some are randomly selected, some are part of a regular survey. Most of our herring catch occurs in Scammon Cove. Consistently, fish are aggregated in this area. My crew, when they're doing surveys for about the first week of October to the second week of October, they'll be driving out of Scammon Cove in the morning to go set nets, and they'll drive the boat across large schools of Cisco, and the schools of Cisco will part ahead of them as they go by, and then as they go by, the school comes together behind them. These fish are aggregating in shallow water, 5 to 30 feet, beginning in the first week of October. They're probably there in September. That's why I sort of refer to these as bay fish. This is not how Lake Superior fish aggregate. By October, these fish are still well offshore, suspended over pretty deep water. First thing to notice is this is an aging error matrix where I'm comparing scale ages against otolith ages. What you get is pretty good agreement between scales and otoliths up to about age 5. You know, we're on 90 or 100%. My staff is pretty agreeable, but as you get older on scale ages, the reliability changes dramatically. And so what I've done with my data sets in early part of the time series, I'm sampling only with scales. Later part of the time series, it's a combination of scales and otoliths depending on the size of the fish. This graphic is one of the things I wanted to point out. This is age structure. The bubble is a bubble plot of age structure of Cisco caught in the Drummond Island refuge surveys through time from 1991 to 2004, regardless of whether it's a spring survey or fall survey. What you see is basically prior to 1996, we got a few old large fish there, but not a lot. We had a big recruitment events occur in 96 and 97, so they were like the 92, 93, 93, 94 year classes. And those year classes, you can sort of follow them through. What we're seeing is a big expansion in the age structure through time. And basically, after about 2003, very little recruitment recurring at all. Okay, and if you remember the age structure for this population, it's very broad-based and not much for recruitment going on. So this population is like the Lake Superior populations. You know, it had 1 good or 2 year classes, and then hasn't done really worth a damn for a long period of time. When Dan came to sample fish with us, you know, we started catching these fish, and he says, "Are any of them under 3 pounds?" You know, these are big fish and pretty old. This is sort of a illustration. A year class strength for fish of Drummond Island is just a cumulative catch rate across all ages that a year class would be vulnerable. And so the 1994 looked like it was a pretty good year. 93, 94 were good. Subsequent ones were okay, and then we've seen a decline in year class strength through time since then. It's funny how it sort of looks like whitefish year class strength and MH1 during the same time period. The bottom graph are whitefish year class strength and MH1 based on Cisco catch at age analysis, and we see sort of the same pattern. Pretty big increases in relative of year class strength through the mid to early 90s, and then a decline through time, particularly rapid decline in whitefish populations. Now last I want to talk about the St. Mary's River. This is a population located along about the middle of the Sugar Island in what we call about 6 Mile Road or so. There's some small islands. You got the river channel, and then you got a shoal that comes up from small islands, and then you get into this. The other side of the island is towards the island, the bigger island. You get this trough that goes for about 5 to 20 feet, and it's in this trough that these fish aggregate for spawning every year. These fish are also in the river system all year long. There are recreational fisheries for Cisco in the river, both on the Lake George side and in the riverside, basically all open water season long. So these fish are always subjected to some level of exploitation. We were helping out Michigan DNR with egg collections when they were evaluating the ability to reintroduce Cisco into the system. And as Dan pointed out today and Jared pointed out today, herring and lake trout, whitefish, they all spawn when we don't want to be out there. These are collections. This picture is taken about November 19th, 2006. I mean, the wind's blowing about 30, 40 miles an hour out of the northwest. It had snowed the night before, and it's about as miserable conditions as you can have to work in. What I wanted to show here was interesting is the maturation schedule for this particular population. So the blue bars represent the proportion of gravid individuals. These are males or females that are gravid, they haven't spawned yet. And so you can see from October 27th through about November 8th, most of the fish are gravid. And then you get a time period between November 8th and November 19th where the proportion of spent fish start to increase and the proportion of ripe fish increases. And then by the end, November 23rd, almost all the fish are spent. And this is data from 1997 through 2014. It's really consistent. This population is isolated and does not spawn over a protracted period of time. This population spawns in like 1 or 2 days, and then it's done and it's over with. One of the ideas that Randy Eschenruder has been promoting in Cisco populations is that they're not site-specific in terms of where they go, that spawning is a learned behavior. And Randy's idea here is that the juveniles learn from the adults. By hanging out with the adults spawn, the juveniles also learn to spawn. So one of the things I did was I went back and looked at the proportion of immature Ciscos in my Sugar Island spawning catches from 1990, well, this is 2010 to 2014. The bottom graph are just individual days or sampling dates, so there's really no true progression, although it goes through years. So what you see is that on average, about 5 to 7% of the males and the females are sexually immature in this particular population. In some years, we're getting between 5 and over 10% of the fish that we catch are immature fish on the spawning grounds in mid-November, sort of supporting Randy's hypothesis that you don't see this with whitefish, you don't see this with lake trout. You go to lake trout, you go to the spawning grounds, it's all big fish. There's no juveniles mixed up in there. See the same thing with whitefish. You go to the spawning grounds, there's no juvenile fish mixed in there. It's all adults. But this population of Cisco appears to be consistent with Randy's idea about how fish learned where to spawn. Lastly, I want to talk about and I gave parts of this presentation before, and that's the role of Cisco in making sea lamprey control more difficult. You know, as if the control agents don't have a hard enough time with everything that's going on. Fish community responses, I believe, are going to have a fairly significant impact on sea lamprey control. So this is allocation of sea lamprey attacks on Cisco in northern Lake Huron through time. The thing to notice is the black bars are A1 marks. These are the different types of marks. And as the fish get larger, the number of attacks increases, and at smaller sizes, the black bars, mostly the marks are A1s, indicating these fish probably die. And that this ability to survive attack increases once you get up, say, over 350, but certainly once you get over 400 millimeters, 420 millimeters, you see more A2, A3, A4, more attacks, marks from that fish survived, which indicates they are surviving attacks to some level. The other thing is that what we're seeing is an increase in marking rates on all species up here, in particular, even on Cisco and whitefish. These are the two lower lines, but they're following the same trends as we are for lake trout. The point here being is that what we see, particularly in the Drummond Island area on the North Channel and the St. Mary's River, is that you catch Cisco early in the year, say May, June through mid-July. They're almost invariably going to be have lamprey. A lot of them are going to have lamprey on them. And if you go to the same area and you catch a whitefish, a lake trout, and a Cisco, chances are the Cisco are going to be attacked by lamprey and not the other two species. So what I'm thinking here is that Cisco are actually providing a buffer to other species when they're small, but once they get large, what the Ciscos are doing, they're providing a food source that allows sea lamprey larvae to survive and grow to a larger size where they really become a true predator. So lastly, in summary, I think what we have in northern Lake Huron really are bay or reef Ciscos. These fish, whether I'm talking, these fish in the St. Mary's River at Sugar Island are spawning from 5 to 20 feet. In Drummond Island, these fish are spawning about 5 to 10 feet over rocky, shallow areas. In the St. Mary's River, it's questionable whether it's rock or a soft bottom. In Cedarville, they're spawning over a mixture of stuff. You'll find them over rock, you'll find them over sort of along the edge of scurpus beds and things like that. But these fish are all in shallow water, early in the year, nothing like we see with these pelagic populations in Lake Superior. You know, so these fish are both pelagic and benthic. They live primarily in shallow areas. I mean, by mid-July, there are not huge, but there are significant sport fishers targeting Cisco in the river and in the Lake Chenaux in 5 to 15 feet of water in mid-July. No self-respecting Lake Superior Cisco is typically found in these sorts of situations. These fish spawn from between 5 and 30 feet. They're always associated with bays, always. Cisco like warm water, and they like bays because I think it produces nice warm water for their larvae when they hatch. You know, in the St. Mary's River you saw, in the Lake Chenaux Islands you saw, both of those age structures were more focused on younger fish, indicating that there's probably more consistent recruitment going on in these areas where I think they're very protected. Drummond Island, we haven't seen much consistent recruitment at all, but Drummond Island, this is exposed to the open parts of the lake. These fish that hatch in this area are sucked out right into the lake immediately by big currents and spring wind patterns, whereas they're protected in Lake Chenaux Islands and in the St. Mary's River. So it appears that we might have two distinct morphotypes. One is a small form that matures at a very small size. This is what I showed you in the St. Mary's River. What we see is these little Cisco maturing at less than 200 millimeters long. I don't see that anyplace else except there. Whereas most of the fish sexually mature by about 300 millimeters. And these fish are concentrated in bays in less than 30 feet of water by early October, certainly in September. The last point is that, you know, Cisco may act as a buffer for other species, but they're also probably helping increase survival at smaller sizes for sea lamprey.